To finish up Chapter 1, Lesson 2, Part C, we're going to talk about this famous function again. We saw this famous function earlier, the sine of A over A, and we were focusing on what happened at that peak of the function. And so now we're going to be looking at the infinity part of that function. So if you remember, this was the shape of the function. The function starts out with kind of a low level of oscillation, and then that oscillation reaches a peak. There's an open circle right there, and then it comes back down, and then it kind of shrinks as it goes back down. It has curved asymptotes in all four quadrants, creating boundary lines that this graph will never cross. And so that's just a reminder of what that graph looks like. We talked about the middle last time and what happens at this peak here, and that peak will always be the number 1 as long as we have matching terms of AX and AX. So our job today is to figure out what's going on the left side and what's going on the right side as X approaches negative and positive infinity. So the idea is the same. We want a match here in these terms, and on the left side, which is over here, this graph is getting smaller and smaller and smaller and smaller. The peaks and the valleys are flattening out, and it's getting, eventually it will get so flat and it will become squeezed between the two asymptotes. So this asymptote here and the asymptote on the bottom are going to squeeze together, and so that's approaching the value of 0. So that's what's happening on the left. As long as the AX over AX matches each other, we have a horizontal asymptote flattening out to 0. The same thing happens out on the right, that we have the top asymptote and the bottom asymptote squeezing together, and what's in between is getting flattened out, and so that will also have a value of 0. And so we have 3 limits: a left limit, a middle limit, and a right: 0, 1, and 0. So you just got to watch this part of the X. What is the X approaching, so that you know what the appropriate answer is. You're always going to force the AX to match the AX, though. So here's an example. And right now we've got a situation where they do not match. And so our job is to bring a value in that would help make those two match each other. So I'm going to bring in, I want to match the parentheses in the upper part. I need it to be regular X, which means I need to throw a 1/3 out here in the denominator, but I'm also going to put a 1/3 in the numerator. My numerator 1/3 will get pulled out to the front. My denominator 1/3 will get multiplied, so that I end up with 1/3 out in front, my limit as X approaches positive infinity, and now I'll have sine of X over just X. And at that point now I've achieved that match I was looking for. And so this would be then equal to 1/3 times, okay, and now I need to know, what does this have a value of now that they match? And it would be 0, and so the answer is 0, 1/3 times 0. Here's another question. This one has a plus sign in it right here, and that plus is going to mean a common denominator first. So the first thing I want to do is separate this problem into a common denominator. So I'll have 5x over its own denominator of x, and then a plus, which, because you're allowed to do this with addition, and then another limit, and I'll have the sine of x over its own denominator, x. In the first term, the x and x can reduce itself, so I'm left with the limit as x approaches infinity of 5. And in the second part, I already have a match between the values in the parentheses and the value below. And so that means that that whole equation would have the value of 0 because I'm approaching infinity. In the first part, I also notice there's no x's left. So I'm looking at this term right here. There are no x's in that term. And since there are no x's, I can drop the limit notation. And so I'm going to get rid of the limit notation and the scribble yellow thing I just drew. And I don't need my limit notation anymore either. And so the answer then is just 5 plus 0. And so the answer to this limit is 5. It also works for cosine, but cosine has a different graph. The graph of cosine doesn't have the peak in the middle like sine does. It has an asymptote in the center. So there's an asymptote coming down here. But it is still going to be flattening itself around the edges here where it's squeezed in between the other asymptotes. So that it does have, it has an asymptote down the center, but it has the same asymptote squeezing in here and pinching that graph together on both ends. So there's an asymptote coming here. So it also has a limit of 0 as x approaches plus or minus infinity. So we have the limit as x approaches positive infinity or negative infinity. So we can say plus or minus infinity of cosine a of x over a of x, as long as there's a match there. That is also 0 on both the left and the right. So for this question, I notice a subtraction, which means another common denominator situation. So I have the limit as x approaches infinity of cosine of x over 2x minus another limit with the common denominator of 1 over 2x. At this point, I look for a match, and I do not have a match yet, so I need to introduce a 1/2 in both the numerator and the denominator. My 1/2 in the numerator will get pulled to the front. My 1/2 and my 2 will combine. So I'll have 1/2 in the front of the limit as x approaches infinity. And I've got the cosine of x over just x now, which is the match I was looking for. And then I'm going to, in my second part of the problem, drop infinity into the problem and at the same time drop the limit notation. So this term here is going to be 0. So I'll have 1/2 times 0 minus, and then in this term we have 1 over 2 times infinity, which is 1 divided by the largest number, which means I get the smallest number, so I get 0 plus. So I end up with 0 minus 0 plus, which puts me on the 0 minus side of 0. All right, that's it. So I promised you a short lesson. I know the day before it was really long, so this is a short one. And you'll work through the sine and the cosine properties as long as you have the matching terms of ax over ax. Okay, and then have a good rest of your day and weekend, and I'll see you next week.